In this video, we're going to look at one example, which is a continuation of the previous example, where customers are coming to a bank according to a Poisson process with an average rate of 8.6 customers per hour. So coming to the bank, 8.6 customers per hour, and now we're going to look at these three parts of this example where we're focusing on exponential, because for the most part it's talking about the time between arrivals. So first, on average, how long would you expect it to be until the first customer arrives? Well, on average refers to expected value, and when it says how long, it's referring to time. So that right there, you distinguish between, okay, this is not a Poisson. This is talking about time, and it's probably going to be exponential because it says how long would it expect be until the first customer arrive. You can always draw a little diagram for yourself, and this is time 0, and let's say here first customer arrives, right? So this is time that this part of the problem is referring to, and that is T1. If you remember the diagram that we had before, right here, that is T1, and then T2, and then T3. In this problem, it's asking for T1, and it's asking for expected value of T1. Expected value of T1. Sorry, T1. And as you probably know from the previous slide, it's 1 over lambda. So 1 over lambda, that is the average time it takes for the first customer to show up, essentially. 1 over 8.6, which is 0.116 hours. So that's a little more than 6 minutes, maybe, close to 7 minutes or something. In part B, we're calculating some probability. What is the probability that the first customer arrives within 30 minutes? First customer arrives within 30 minutes. So in this case, we were talking about the same interval that we're talking about here, T1, the time it takes for the first customer to arrive, and what is the probability of that being less than 30 minutes? Within 30 minutes means less than. And because it's a continuous random variable, it doesn't matter, less than or less than equal. So probability of T1 less than or equal to 30 minutes. Because our lambda is in terms of hour, we're going to convert that to hours. So probability of T1 less than half an hour. And that is, if you notice, this is the form of a CDF, right? CDF of exponential. It's right here. 1 minus e to negative lambda x. So we're going to use that. And just replace the parameters. Now here it is 1 minus e to negative 8.6 times 0.5, which is going to be 0.986, about 98.6% chance that you see the first customer within 30 minutes. Very high chance. And again, make sure your answer makes sense. In this case, we're talking about a Poisson process with an arrival rate of 8.6 customers per hour. So there should be a really good chance of seeing at least one customer within 30 minutes. What is the probability that the fourth customer arrives more than 6 minutes after the third customer. So here again, we're talking about inter-arrival time. Fourth customer arrives more than 6 minutes after third customer. That is, if you want to, again, visualize that, you have these customers coming in, and then here the third one, let's say here is the fourth one, and we're talking about this time here, which is T4. More than 6 minutes. What's the probability that T4 is more than 6 minutes? Probability T4 more than 6 minutes. And again, we'll have to change minutes to hours because lambda is in terms of hours, or change your lambda to minutes, whichever way. Probability of T4, and 6 minutes is 0.1 hours, right? So 0.1 hour. So as you can see here, we're having probability of T4 more than, and to an easier way to calculate that is to calculate the complement of this and subtract it from 1. So that is equal to 1 minus probability of T4 less than 0.1 hour. And now here is the CDF of exponential. And again, it's exponential because we're talking about inter-arrival time. 1 minus CDF of exponential. Again, here, the highlighted part is also 1 minus e to negative lambda x. So that is just e to negative 8.6 times 0.1. If you do the math, you should be getting 0.423, about 42% chance that the fourth customer arrives more than 6 minutes after the third customer. And if you notice here, if this fourth customer was fifth and this third customer was fourth, or you change that to any two consecutive numbers, the answer wouldn't change. So it really doesn't matter if it's T4 or T5 or T6. It's time between arrival. You can actually simplify that and just say probability of T more than 6 minutes, which is a really important point. We're going to talk about that in the next video.